Hi team, so sorry I'm going to be out with a PLC meeting for our time tomorrow, but I wanted to give you a bank of some short mini lessons that you could use to get your work completed in Module 7 and hopefully help you with some of the concepts that you're seeing there. So let's get this started with 7.06, multiplication of polynomials. I'm going to jump right into an application. Where will we see this? If I want to find the area of a rectangle, I have to multiply length times width. What if the length and the width are polynomials? For example, if I have a binomial 2x minus 5 to represent the length, and then I have a trinomial x squared plus 3x minus 2 to represent the other dimension of my rectangle. To find the area, I would have to multiply 2x minus 5, all of that answer, by x squared plus 3x minus 2. So this is an example of multiplying a binomial times a trinomial. The process I go through is the distributive property. You take your first factor, and in this case, our first factor is 2x minus 5. It's a binomial. Bi means 2. That means I have two terms. What are the terms of the first factor? 2x and negative 5. Those are the two terms of the first factor. I need to multiply both of those terms by everything in the second parentheses. No matter how many terms are there, I need to multiply 2x by all of that. So 2x times x squared plus 3x minus 2. And I need to multiply the negative 5 times all of that. So negative 5 times x squared plus 3x minus 2. So you can see how, because we have a binomial as our first factor, I had to separate the binomial into two terms and show that I'm multiplying each of those terms by everything in the next parentheses. Once I do this, I can apply the distributive property. When you have a term right up against the parentheses, that's where we're distributing. So 2x gets multiplied by x squared. Remember, 2x has an exponent of 1. And when you're multiplying, you add the exponent. So 2x to the first times x squared is x to the third. Then we multiply 2x times 3x to get positive 6x to the second. Since it's x to the first times x to the first, that would be x to the 1 plus 1, which is 2. Again, you add the exponents only when you're multiplying. So then we distribute the 2x to the minus 2, and we get negative 4x. So we've just distributed 2x times x squared, 3x, and negative 2. Moving over to the negative 5, we're going to distribute that to the x squared to get negative 5x squared. Negative 5 times the next term, 3x. A negative times a positive is a negative, so that's negative 15x. And then negative 5 times negative 2, negative times a negative is a, so that would be positive 10. Now I've done all the multiplication because I've distributed each of the terms from the first parentheses to everything in the next parentheses. So my next step is to combine like terms. Like terms have the exact same variable and exponent. So my first term here has an x with a 3 as the exponent, x to the third power. I don't see any other x to the third powers, so I know that my leading coefficient is 2, and the degree of my polynomial is 3. Now I can look to see my next term, which is x to the second power. I have two terms with x to the second power, so those are like terms. When I combine like terms, I'm only adding and subtracting the coefficients. So positive 5 plus, positive 6 plus negative 5 is positive 1x squared. I can put that 1 there, or I don't have to put a coefficient of 1. And then I move on and I combine the x term. So if we look, we have negative 4x combined with negative 15x. And when we have the same sign, negative 4 and negative 15, we add and keep. So that would be negative 19x. And then bring down my constant plus 10. I don't have any other constants. So I've completed by finding the area, multiplying length times width. And this is how the process we want to work through when we're multiplying any polynomials is by applying the distributive property.